So welcome, Friday, NDC. Has everyone had a good time so far? Yeah. Awesome, great. Thanks for coming to watch this one. I'm going to kick off by this. This is event-driven architectures, okay? I'm a walker, by the way, so sorry, cameraman. But we have producers, channels, and consumers, okay? So hands up if you've seen this kind of thing before, drawn this diagram in your organization. Yeah, most people, okay? So you've come to the right place. And those who have not, in one slide, this is event-driven architectures. If I was to encapsulate the whole thing here, then we have producers and we use messages onto a channel, onto a queue, onto a broker, onto a topic, and then we have consumers that listen to that. So the question is, why something like this can get so complicated? Okay, even something so simple as this. We have discoverability problems, okay, boundaries of information, choreography, orchestration, ownership, idempotency, being able to retry things with side effects, eventual consistency. All these things that will come up when you build event-driven architectures. And it's not an if, it's more of a when. And that's what we're going to be talking about in this session today. It's actually navigating some of this complexity, diving deep into it. Having a look at it, what does it mean, this accidental complexity that will come and get you? And then I want to look at domain-driven design and think about how can that help us build solutions to avoid or manage some of that complexity. Before we do any of that, I introduce myself. My name is Dave Boyne. I'm a core maintainer of an open source project called Event Catalog. I'm a cowboy, I guess. I do open source full time now. So previously I worked at AWS. I decided to leave that to just work on open source stuff and also do some consultancy and freelance to actually look after a family. Because open source, as many know, do not pay the bills. So I was at speaker dinner the other day and someone looked at this photo and said, "Wow, is that you?" And I was like, yeah, God. This is what open source does to people and having 2 kids. So I kind of don't recommend it, but no, I love it. It's really cool. I actually love governance, standards, and developer toolings. I'm one of those people. I think it's super important. So if you're into any of that, please come grab me later. It's actually my first time at NDC, any NDC, actually. So I really appreciate being invited to speak here. And I just got to say, the community has been very welcome and very awesome. And it's been great to honestly hang out with you all. So what are we going to speak about today? 3 main parts, really, in this talk. Number 1 is warning signs of complexity. Okay, as we start building event-driven architectures, what are the warning signs and how do we notice them? Okay. Next, we're going to be looking at domain-driven design. Is there a correlation between domain-driven design and event architectures? Is there an overlap here? What value can we get from that? And finally, close to my heart, I want to talk about governance, standards, specifications, emerging trends that you can use and look at to manage some of that complexity. At the end, I have a summary with tons of resources, a link, so you can feel free to grab images or whatever, but everything is at the end anyway, so you can sit back and relax. So should we get started? So the question is, if we take a step back, right, and we think about why is it that we're talking about event-driven architectures? Now, many people in the room will say we've been building message-based systems for years. There are books like Enterprise Integration Patterns that go back, 22, 25 years, okay? And if you look at white papers back even further, we've been using message-based systems for 30, 40 years. So why is it all of a sudden that event-driven architectures are now the hype, I guess, that we should be using this, should be using that? It's because what I think is happening is that event-driven architectures are just becoming more accessible to everyone, okay? We don't have to manage brokers that much. We can use things off the shelf. An example here, we can use Azure Event Grid. Many of you might be using that. We can use PubSub, and we can use SNS, SQS, EventBridge on AWS. We can lean into the shoulders of these companies and actually just start using some of this technology. Confluent, big Apache Kafka enterprise here, very big in this space. Solace and Gravity doing event-based API management stuff, which is really cool. Cloudflare is coming up from the ground up, eating a lot of the pie up here, actually innovating in this space, doing some very, very cool stuff. We have new startups like Ingest and Restate, Temporal, coming off and actually allowing us to do things like durable executions, which is very interesting. Being able to have orchestration code within a function, right? And actually coming back in, here is an event, I'm going to execute this part, pause, and execute this part a year later in the same kind of thing. So very interesting models coming out. And the question is, many people say, why should we use event architectures? We start Googling, we start researching, and we're promised this holy land of scalability, decoupled architecture, fault tolerance, business agility, evolutionary architectures. We can start architecting to allow our business to kind of grow and be fast. And yes, these are benefits. I speak to many people in the open source community, many clients, many companies when I was at AWS are experiencing this, are having this, and this is great, this is fantastic. It's becoming easier for us just to publish a message, okay? We can take a payload, Avro schema, we can take a JSON schema, whatever else. We can publish this onto a channel, being a queue, a broker, whatever else. It's becoming easier for us to do this. This is great. We have this value over time. We have this sense of value and this achievement in our architecture. We have this bump, initial bump here that we say, okay, we have the producers and consumers. This is going great, this is awesome. We had more consumers and more producers come online, and we had this like illusion of value in this architecture type. Now, the problem with all of this is that the value tends to plateau over time, okay? Why is that? It's because when you start building these types of systems, we start to have complexity creep in. We start to have this mindset of implementation first, because it's really easy to do just to publish a message onto something, versus behavior thinking. We start to have like lack of standards, governance, discoverability, who's doing what, who produces what, who consumes what. Well, we're told producers don't know about consumers, so we end up in a weird world. Leaking information in your events, what goes inside your events, who knows? Even coupling down to the event itself. When we map this back on this kind of graph, what you'll often see is this complexity, right, with event architecture just rapidly goes up at some kind of scale. At the start, it's not too bad. You've got control. But over time, as your organization starts to evolve and you start to use it, complexity is here. Everyone, I do a lot of, I said, open source work. Everyone I speak to has some levels of this complexity come up. It's astonishing, really is. So lack of standards, unclear domains start happening. Now, when we take a look at complexity, there are often different types of complexity that we often talk about. Many people stop at 2, but I think there are 3. Number 1 is essential complexity. Your domain, your organization is naturally doing something that is complicated. Right? So I was chatting to someone yesterday about like credit scores in the US. Like things are naturally complicated and models that they have to use. On another layer, as architects and developers, we tend to kind of stop here. But there are important things to notice. Idempotency. If we're going to retry the event, do we have side effects on our consumers? Exactly once processing, retry handling, fault tolerance, cap theorem, partitioning, and all this kind of stuff that we have to know about when we start building distributed architectures, which is fine. But then we have accidental complexity, okay? We have this kind of versioning. How do you version your events? Coupling levels between your events and your domains and your models. Governance, big balls of mud, ownership and boundaries. All of this is a problem with event architectures. And this is the area which we're going to focus on in this talk. If we rewind, back in January, I was kind of prepping for this talk, and I wanted to dive deeper into complexity, and I have this in the resource at the end, but Peter van Hardenberg had an awesome talk on complexity in software architecture, and he said this, is that it's not linked to the size, okay, but it's linked when the systems start to integrate with each other. It's really got me thinking about event-driven architectures. It's fascinating, actually, when systems start to integrate with each other, which is something so simple, again, ends up so complicated with more producers and consumers growing and channels and queues and all this kind of stuff. So let's dive deeper. Let's have a look. Back to this. We have producers, channels, and consumers. Us as architects and developers, we want to build an event-driven system, so we do that. Next thing we do is we have consumers come on board. We're publishing that something has happened, an event, an immutable fact in our system, and consumers say, thank you very much, this is awesome. We go to our whiteboards as architects and we start drawing other things and cues and channels, and because this is the way we're kind of told, this is great. Other teams come on board and look into the room and say, I'm also going to do the same. This is great. I want a piece of that. I want to actually build an event-driven architecture. I want to have cues and messages and events. And it's interesting because we walk away as architects and developers and we say, we are loosely coupled. This is beautiful. We have lines and graphs and boxes and people don't know about each other. 9 times out of 10, all we've really done here, okay, just ended up in some kind of big ball of mud, distributed mud. Now, big ball of mud, the term comes from domain-driven design, but it even comes before that in a white paper here by Brian Foote and Joseph Yoder. Again, the resources at the end, I'm not going to read the whole thing, but they start talking about some interesting characteristics of this architecture of big balls of mud. Number one is like unregulated growth. So producers and consumers are coming and going, and producers are just doing messages. That's interesting. Information is shared freely amongst the system. Interesting, so we're publishing messages. What goes inside your messages, who knows? And then the overall system may have well never been defined in the first place. And these are characteristics. These are things, these are warning signs as you build architectures. And as I said at the start, things are very simple, but it's only when we get to scale and things like that, you start to see these characteristics come through. So warning signs in event architectures, I say the first warning sign is like, do we have a distributed big ball of mud? Probably, at some point, yes. Lack of design, that free information, that unregulated growth. So what else is there? Let's take a step back again. Something so simple. What goes inside our events? We are the orders team. We have been tasked to raise an event. This is a JSON schema event, a JSON event, and we have to raise it. The order has been placed, okay? So in your events, you can pretty much put anything in there. Your broker will tell you to put some metadata in there, or whatever. This is using Amazon Event Bridge as an example. So what we do is we say the order has been placed, because we've read online that an event is a mutable fact. Great, this is actually pretty good practice. Order has been placed. Next, we have the source. Okay, this could be the domain or the service that the myapps.orders. Again, this is okay, maybe some good practice here. Next, we decide, okay, what goes inside the envelope? We've defined the envelope, what goes inside of it. Now, this is up to us. So we decide to say the order ID and the user ID, and we publish this event into the ether so consumers can come and listen. And that's it. Consumers do come and listen, and we get value from this. Again, that initial bump in value. 3 months down the line, what happens is we get asked to do the order cancelled event. So us as a team, we say, we've done this before. We can just copy and paste what we have. So we do that. We have the order cancelled, myapp.orders, that's fair enough, the detail, the envelope. And then we have this, a reason. It is no longer needed. Okay, that's kind of interesting. A consumer could probably send an email, we cancelled your order because you told us it was no longer needed. Might be value in that. Next, we have T_W for a type. When you cancel an order, T_W. Does anyone know what T_W means when you cancel an order? No one in the room. I don't know what it means, and I made the slide. But what I'm getting at here is implementation details are leaking. No one knows what type T_W is, but you know, we don't care, we carry on. And we also chuck the user in there, but this time we have a user object and we have an ID in there. Okay, well, last time we had the user ID, but you know, consumers can work that out. And we have the first name, last name in there. Okay, is this like PII information? Don't know, don't care. And we kind of just carry on into this world because we're excited, right? So what happens is it's just another message. It's just another message, and we continue to go in this cycle. So the payments domain or whatever it is, you know, we got created and declined and cancelled. Fulfillments are completed and started. And then down here, interestingly, the invoice team, they start to do something weird. They start to have commands as events. They start to say, hey, we want to send an invoice email onto this broker. Okay, interesting. Next, we continue, the evolutionary, the story continues. This time we have CRUD-based events. Awesome. That the order has been updated. Why has the order been updated? What's updated about the order? Okay, has the order changed? Have we changed some details and some? Has the order quantity changed? Don't know. But we have CRUD-based things because why not? And we continue, and the story is the same, and we end up with this weird complexity, but now complexity is in event design. Complexity is with this mindset of YOLO events, being able to just publish messages onto this thing. And then we have lack of standards and exposing domain information and all this kind of stuff. So, warning sign number 2. Again, these are quite common. So let's look at the third one. Question is, number 1, what goes inside our events? We just briefly spoke about this, but the events actually have a name and different types of events. So what we decided to do is use notification events. Okay, we've read online, this is great, we can do this. So we notify downstream consumers that something has happened. Notification events tend to be thin in contrast. Okay, so we have a small contract. Small contracts are great because they don't require too much versioning here. But every consumer, as you can see, is happy. And the real question is, well, how useful is the user ID and the order ID? What happens, you start to accidentally introduce some kind of back pressure. Now, there are trade-offs to consider here. You might actually want to use notification events. Your consumers might actually need real-time information, so this is a pattern that you might want to use. But most of the times, these are patterns that you introduce accidentally. I'll tell you a story. Once I was in a startup based in Leicester, and we were doing like life insurance products. So I was a founding engineer there. We're building event-driven systems, had like 5 engineers. A whole point of this whole thing was like it was a business-to-consumer thing. So we wanted to go viral on Facebook. So we always had like 20 or 30 subscriptions a day. We always wanted to pump more, so we pumped more money into Facebook. And I remember walking in one day into our organization, and a developer coming up to me and saying, Dave, we've gone viral. And I'm thinking, this is it. This is the point of my life. So it's kind of like a scene from a movie, and I'm walking down, I'm looking at the graphs, I'm like, yes, that looks green, it's going up. The graph's looking green, going up. Then I sit down trying to figure out what the hell is going on, and realistically, unfortunately, all that's happened is we've added just more consumers onto this architecture type. More consumers with notification events, pushing back onto our producer, requesting more information, and raising some more metrics. So what's the alternative? The alternative is, well, okay, Dave, we'll put everything into the event. You tell us not to do notification events, let's put everything. Okay. So now we have something called event carry state transfer, a different type of event. Now, your consumers will say, thank you very much. I don't have to go anywhere now. This is awesome. I can keep a local copy of this, whatever that looks like. Now, what happens in the future is that the producer says, we need to get rid of some information on this event. We need to change the contract and the schema. So what tends to happen here is, okay, well, do you know who's consuming your events? No idea. So what happens here is, well, the first consumer says, thank you very much. I'm following some practices, maybe like Postal's law, right? Being conservative in what you do and liberal in what you expect from others. So we only validate what we need. So that thing down there it's okay. The one at the bottom here is like fuming because you've just broken them, but you had no idea because you don't know who's consuming your events, because that's the whole point, we're loosely coupled. And number 3 is just kind of melting away in their own existence. And the only reason I added that, because I like that emoji, I think it represents my mindset at times. So, again, what have we actually accomplished is just weird complexity that's coming in. Lack of design, contract coupling, lack of version strategy is often an interesting one with all of this. What I find interesting as you talk to a lot of people and you work with a lot of clients and dive deeper into this space, is this idea of like APIs, right? APIs versus events. If you go into any organization in here, I can imagine 80% of you would push back if I said, we need to create an API. Someone would say to me, we need a specification, we need a business case, we need all of this kind of stuff. We've been building APIs for many, many years, and we have standards and governance of how we do that. We treat APIs like this, you know. But events is like, events needs to be that, but events is just this free-for-all thing. It's like, hey, what do we put in our events? We don't know, we just kind of publish them. It's a very weird contrast that we have. And that's the third one here, really, is like lack of event design, coupling through event design, and all this complexity that comes with all of that. So what can we do about it? And this interesting thing here is like this thoughts of like implementation, okay, implementation first mindsets. And I think we're falling into a trap of this, and it's so easy to do this now. You can, again, install an SDK and publish an event, a message onto any kind of broker out there in literally seconds, in minutes. Implementation first. But equally, we have this idea of behavior first. This is where domain-driven design comes in. What can we actually learn from the behaviors of our systems, our domains? And actually, is there value there? And I think there is. I think there is a ton of value and overlap with domain-driven design. A book that is 23 years old, what can it teach us about modern event-driven architectures? And the answer to that is a hell of a lot, to be honest. And as I said, there is huge overlap. But if we move event architectures to the side for a minute and just step into domain-driven design, let's have a look at what we can pick from this book and actually apply it to our architecture to control some of this complexity. And with the complexity, you'll notice that it's not really necessarily about removing it, but we have to manage it and bring it down. So what does domain-driven design teach us about all of this? Okay, so domain-driven design tends to be split into two things, which is strategic, I hate that word, I struggle to say that word, strategic design, and then we also have technical design. So the what and the why and the how, okay? So when you start to map these out, you'll see something like this, ubiquitous language. Okay, the language in which we talk in our context of our domains. We have core domains, supporting and generic domains. A core domain is like what is core to your organization. It provides competitive edge. Okay, it's actually quite complex in nature because it provides the competitive edge that other people struggle to copy this. Supporting domains actually support the core, so like a custom CRM platform. It's not core to your organization, but we have to have it because it supports this one. And generic domains, things like OAuth, payment, Stripe, this kind of Auth0, whatever else we use, things we don't want to have to manage ourselves. So there's lots of stuff going on here. We got bounded context, we have domain models. On the how, we have, pretty cool, we have events, entities, we have aggregates, factories, context maps, as you can see. Now, unfortunately, in this talk, I don't have the time to talk about all of them. There are literally conferences out there diving into all of this in a whole day or two. But there are things we can actually take from this and apply to event architectures. And actually, as I said, control that complexity. So here, if we look through an event architecture space and lens, all we're talking about really here is on the left is getting our shared understanding of the system and how that can help us. And number two is actually using messages to communicate between boundaries, okay? So why do we care about getting a shared understanding with event architectures? And it's an interesting thing because on the one hand, we have the domain experts, the business or the customers or the people that understand what it is you're trying to do. On the other hand, we have the implementation team, more often the developers. What tends to happen is this like translation of things that happen. An example here in the top left, we have 4 wheels, we have windows, we have a boot and a bonnet or whatever. And on the right, the developers say, yeah, okay, we got 4 wheels, windows, boot, bonnet, and we deliver a bus, okay? Which is interesting. I remember years ago, about 13 years ago, I used to work for a company called Compare the Market, which is a big UK company here about price comparison with like weird meerkats. But the meerkats were probably the best bit of the job. But I remember going to meetings, so I was a software engineer, and luckily for us, we had ThoughtWorks working for us for 2 years. I learned a shitload from ThoughtWorks. Awesome, awesome stuff. But I remember going to these agile transformation, agile meetings, okay? And we do these inception meetings, and I remember the business It was the business and the developers, the business. The business would turn around and say, we need to do this week. This is the kind of stuff we want to look at. I remember sitting there just as a software engineer and thinking, okay, well, I'm in this room to transform what you mean into code. This is why we're smart. We're smart architects. We're smart developers. This is what we get paid to do, translate whatever they're talking about into something, okay? And it's this weird feeling when I look back on it now, I think it's so completely wrong, is that the idea really is what we need to do is actually move things together. Because if we don't, it's the assumptions that are getting released into production here. So that event architectures, the things and the events, the naming conventions, the schemas, everything we're talking about is just completely different to the expert's knowledge. So what domain-driven design really talks about here is actually moving people together, collaborating through domain discovery. So we can actually work with domain experts and actually release what they're talking about, use the same language, the language we use in our events, our models, our schemas, translate into something that makes sense. So the question is, well, how do we do that from a domain-driven design point of view? Well, we do something like domain discovery techniques, and there are loads of them. But what they recommend is that, visual collaboration with teams. We have teams of domain experts working together. And the whole idea here, the fundamental thing here is just to get that shared understanding, okay? Because that gets translated into something else. Now, how do we do that? Well, there's one thing in particular that has huge synergy with event-driven architectures, thankfully, is event storming. So hands up if you've done event storming before. Probably about a quarter of the room, a third of the rooms. Cool. So event storming, what this is we get domain experts in a room. We have like 10 people, 20 people, 30 people, whatever it is. And we're actually using events to discover the domain, funny enough. So event storming is an interesting one. Many people look at event storming like, well, we have legacy systems. We can't just event storm. But event storming has different styles and techniques which you can use. We can, number one, improve our system and just explore it with domain experts and people. Because remember, in organizations, people come and go. On the right, we can envision a new service or an architecture or whatever it is we're trying to build using event storming. And again, down here, we can dive deeper into more complex things. So event storming, we can actually use to get that shared understanding here. So what I want to do with you is actually dive into some example, right? Some example of envision, okay? So let's have a look at this company. So this is BrightPath. This is a fake company that we're going to try and build. This is an online learning platform. People sign up. They get recommendations on their courses. Recommendations, maybe using some nice models, whatever else. That's our core domain. Okay, so people sign up and do that. We have like content management systems maybe to do stuff. So anyway, what happens? Step one, we come together and we create some events. Okay, so this is a chaotic exploration between people in the room. We don't necessarily talk to each other too much. We have duplications of events on this wall. So we map the events and we start to map them up. So as you can see here, we have like user creates account. That's an event. We're already talking about events, event architectures. We're actually using events as the core of our discussions. Recommendations, rejected, accepted, user viewed lesson, all sorts of things. The next thing we do in event storming is where we move these and we put them in a timeline along the bottom, okay? So we have this timeline here, and we can actually start saying, okay, well, what happens? The user creates an account. They can change the preferences. A new course has been added. They enroll to a lesson or a course. What is a lesson? What is a course? This kind of stuff happens. So we can start to visualize this thing. Now, most of you in this room could probably already take that and actually get a good understanding of what I'm talking about. The next stage in which we do is we actually start to map things like commands and queries. So let's take a step back. What we're talking about here still is event-driven architectures. Different messages that we use on these particular channels. So command is something that we command that can be rejected. Please do something for me. No, we cannot do that. Okay? You often see that in like post requests over HTTP protocol and things like this. Queries, the same thing. Please get me some information. Oh, here it is. There you go. More of a kind of synchronous stuff going on here. An event down here is like an immutable fact. Something has happened. So to put this into context, here is my dog. My dog is very weird. But my dog says, I want a toy. Okay, it's a command. Now, I can give the dog a toy, But sometimes the dog eats the toys, so sometimes I say no. So it's a kind of this rejection here. The query here is what toys are available, in this context, and then I can go and buy a toy and the toy has been delivered. So in your architecture, you start to have most of these things can be mapped out using this particular language. And then what we do in event storming is we do exactly that. We have actors in the top left. We have users that create an account, a command that we do. We have the user account has now been created, as an example there. We can start to see the flow, the commands, the events, this command down here, this new course added, which then triggers a command, which triggers another event. And we can start just to map this and get a shared understanding. In these discussions, there is conflict. Conflict is the best thing. Conflict where we talk about terms, terminology, users, models, ubiquitous language. We talk about, it's not a user, it's a customer. It's not a lesson, it's a course. What do you mean it's a course? When I was at Compare the Market, it was all about risks and insurances and policies, and so much time was wasted translating what they meant into the code, into the events. It's just bonkers. But this is the value, and I have at the end in the resource pack, there's an awesome domain-driven design GitHub repo, and I stole that from there. From conflict, we grow and gain new insights. And this is the best part of event storming, I think. And then what happens over time is, yes, we add hotspots. So questions that we come back to in the future if we want. What happens if we have an unauth flow? Are we going to build our own payment system or not? What is a course versus a lesson? So we just start to get the shared understanding and time goes on. We start to map systems to this whole thing. Up there, top left, we're using auth0 because guess what? We don't want to roll our own auth. This is a generic domain. Down here in the bottom right, the same thing with Stripe. We don't want to manage payments. But we do want to manage lessons, assessments, recommendations. This is our core domain. So we start to group these things up. And as you group these things up, as you discover these things, you start to see like collections, okay? Collections and these boundaries start to form, which is interesting. Now, when you do this in person, in an organization, you see something like this. Obviously, there is only so much I can fit onto a slide, but you start to see this thing that represents your system and what you're trying to do. And remember, the key here is just that shared understanding. And I think domain-driven design, even if we stopped here, can give us lots of value. The alternative is unregulated growth, lack of designer structure and YOLO events and just going for it. But we can use domain-driven design, have structured growth and thought and a shared understanding in talking about domain events, talking about events and what goes inside the payloads. So the question is, even if we took that and we start using channels and messages, are we loosely coupled? Do we have what we need? The answer is, well, probably not. So what else can domain-driven design give us in this architecture type? Well, it proposes already to us the idea of bounded contexts, okay, groups of elements. So what is a bounded context in terms of domain-driven design? It's a boundary that encapsulates and fulfills a particular business need. Now, many might think a bounded context represents a microservice. You might have a microservice in there, or you might have many microservices in there. But it's a boundary, it's a language that we use. We're already using the word loosely coupled here. So there's great synergy between this and event architectures. What you'll realize too in a bounded context when you start to dive deeper is the domain model, value objects, entities, policies, domain events, application layers, all sorts of things, okay? These are more of the tactical design of domain-driven design, but there are still things in here that we can use. Things like ubiquitous language in your events. The lesson has been created. The lesson has been updated, whatever it is we decided to do. The lesson in this context means something completely different to the lesson over here for that team. So we define this as ubiquitous language. An example of that is this. We have someone on the left here say, I'm going to teach you a lesson, and hopefully you walk away learning something. And then on the right over here, someone's going to teach you a lesson, and probably walk away with some kind of black eye, which is not so good. So from event storming, we can create these boundaries and these contexts. We can create these things and these ideas. We've got the recommendation engine. We've got lessons and assessments. If we take it another step further, domain-driven design will tell you actually assign teams to these contexts or teams to multiple contexts, but not necessarily teams to one context. Because as they kind of suggest here, is that complexity tends to come from that. But the question is, okay, so let's say we use this to map this event architecture. The question is, how do we communicate between the two? Well, thankfully for us, we can use event-driven architectures to communicate between boundaries. So the question is here is like, well, okay, if we do this, are we loosely coupled? And the answer to that is no, not at all. And the interesting thing here is like how we consume events from boundaries, right? Just couples us directly back to something. So it's an interesting thing with event-driven architectures is that as you build these things, you are conforming. You're a conformist by default, okay? So domain-driven design has ideas of bounded context maps, how you map messages between different boundaries. And as I said, by default, everyone in here, if I was to raise the order has been placed and you consume it, you are conforming to the model. You are a conformist. Now, this may be intentional, but most of the time it's probably not. But by default, you are a conformist, which might introduce coupling here between the models of the schema itself. So what options do we have here? Well, we can introduce something like an anti-corruption layer on the boundary. So as a message comes into the channel, we can actually say, no, we don't accept your order created or updated. We're going to map that into something we understand, our ubiquitous language, our models. Okay, so we're protecting ourselves from everyone else, from the producer, and creating this layer. In event-driven architectures, if you dive deep and you start to see these things start to emerge, okay, you start to see like everyone, we've been doing webhooks for many, many years, 20 years. Companies now are starting to invest in actually being able to publish messages directly onto your channel, removing managed webhooks. I think there's going to be a huge spike of this, but this is an example of a reason why you might want to use the anti-corruption layer, because we take a generic domain like Stripe, we take the event, and we don't want to obviously model directly onto that. So again, what can domain-driven design teach us about any of this is we can use open host service. Open host service gives power to the consumers. Open host service says, no, I'm going to push back on you as a producer. You're going to produce a public language that we agreed. So the recommendation engine in this example says, okay, I'll map my event into that language. Different relationships, different communication levels, different levels of complexity here. Now, what you'll see in event architectures is this idea of dumb endpoint smart pipes, if you want to do this. I'm not too sure about it, but what happens is you can actually use the channel and the broker to do your anti-corruption layer, your open host service, your filtering. You can actually publish an event to say, okay, I'm going to publish my model. Consumer says, I'm going to consume a model, but we push the responsibility onto the broker. Now, the question as I have with these kind of patterns, well, who owns the mappings? Who owns that responsibility onto the broker? And if you're using something like these and these kind of patterns, that's something you've got to kind of consider in the trade-offs there. Again, still exploring bounded context maps, partnerships, you'll often see that we want to work with this domain. We are close proximity to this domain, so we work with them. We raise events and messages with them. Okay, thank you very much. We agreed a domain object. Now we're sharing things. This introduces a high level of coupling between the schemas, but this might be okay for you and okay for you to do. This is called a partnership. The opposite to a partnership is this, is that we decide to go separate ways. Now, this is fine in event architectures. You know, you don't have to consume. You can actually duplicate the effort here, but there are, again, different trade-offs here. These are different countries or different organizations or sub-organizations, whatever that might mean. But again, domain-driven design talks about mappings, bounded context maps. So the question is, which one do I use in my event architectures? And that's a hard question to answer, but there are things you can use to help you steer that decision. Number one here is the level of communication that is required, okay? So at the top, we have partnership. High level of communication is required between the teams. I'm going to change the payload. I'm going to break you. Thank you very much, okay? Number two is conformist. I'm just conforming to the model. Very similar, but maybe not a partnership, but I'm just going to consume whatever you give me. These require a high level of communication. Down the bottom, not so much. If you don't want to communicate with the producer, maybe use these kind of patterns in your context. I don't know, I was thinking as I was making this slide, I think there's complexity actually linked to some of these too. A complexity may be linked to some of this communication styles and practices here. So that's probably something you ought to consider. Another thing here is this is interesting, like context. Okay, we talk about bounded context. I think there's also thoughts of context of the broker itself. We can use the same broker in different types of contexts. This is a quote from Vladik. He's the author of Learning Domain-Driven Design, which is a fantastic book, by the way, I recommend. But he says the cost of change is proportional to the distance between components. And this is an interesting one that trips a lot of people up with event architectures, this idea of private and integration and public events. We're using the same broker, we're using the same technology, what does it all mean? Well, if we used Kafka here as an example, the private events inside of the domain are completely different to the events that we're raising outside of the domain. But it's so easy to fall into the traps because we use the same broker. So an example would be private domain, that type TW that we have. Doesn't matter, it doesn't care. We understand what TW means in this, thank you very much, in this use case. And then we have public events, schemas, versioning, contracts. We can't do what we want with public events because they're integration events. And it's very clear and it's very useful to understand the differences here. So the question is, what can DDD help us learn about event architectures? And I think quite a lot. I think the alternative is we build big balls of mud. And it's very easy to fall into that trap, especially nowadays as we have more and more companies coming up and helping us actually get on board with event architectures. And many people fall into these warning signs. So I think we can use domain-driven design to help us scope some of this stuff, get that shared understanding of this stuff. But there's one fundamental problem with event architectures that many people also face, which can take the whole thing down. And it's one sentence in event architectures that we often see as we build these things, okay? One thing that will make that happen is that we are told as architects and developers, when we build this thing, that producers don't know about consumers. This is the whole point of event architecture, loosely coupled. We can publish events into the ether and people start to consume them. This is fundamentally the problem. Why is that? Common questions start to arise. At the start, you might not see this. Some of you might already see this. Some of you might already be in a mess. What happens is the question is what events do we have? So I've just joined your organization. I've been tasked to do something. Well, I know we're using Rabbit, we're using MQTT, we're using whatever channel it is, doesn't matter. But what events do we have? Okay, so the architect and the developer turns around and says, okay, well, we have a GitHub repo. Go look in the GitHub repo. Okay, fine. So I look around. I say, what's the payload of the event, actually? And the developer just says, I've told you, go look at the GitHub repo. Okay, fair enough. So I decide to go in there. I want to make a change to this payload. I want to add something, remove something. Who am I about to break? Don't know. We don't know because we don't know who's consuming what. And it's kind of this interesting thing, and many people honestly are falling into this trap of that producers don't know about consumers. We take it too literally. Yes, technically, it makes sense that we are decoupled, we have responsibilities here, but it doesn't mean, I feel like it doesn't mean we can skip governance, okay? And what do I mean by governance? I think there are things out there that can help us, thankfully, in the open source community, okay? A community I do a lot of work in. So, I guess everyone here's heard of OpenAPI. A lot of people, cool. So OpenAPI specification allows us to document our APIs, right? It's been around since 2011. Originally was Swagger spec and then moved to OpenAPI. they're still innovating. They're still doing some cool stuff. They're doing overlays. Has anyone heard of overlays this year? So overlays was recently announced to add things like documentation and things like that to our API specification. They released Arizo specification on the right. Has anyone heard of that? Not many people. Arizo specification is workflows. Can we document flows and workflows in our organization? Now, event-driven architectures is very interesting because we have a user that starts a journey and ends a journey. And what's happening in between here is, guess what, a flow of events. So we can start to use specifications to do this. And here in the middle, we have cloud events. Has anyone heard of cloud events? Cool, yeah, a few people. So earlier I said what goes inside your payloads, the envelope. That's still up to you. The envelope is now standardized. Why is this cool? Because it allows us to communicate with systems using the same kind of language, the same envelope itself. So the integrations between systems become a lot easier. X-registry, has anyone heard of this one? Cool, yeah, nice one. X-registry is like a fairly new thing from folks at Microsoft, but it's around discoverability endpoints, so standardizing things and helping some of these questions that I asked earlier in more of a standard way. And then finally, we have async APIs. Anyone heard of async API? Cool, well, that's awesome to see. Async API is a great initiative. It's actually a specification that was forked from a friend of mine called Fran Mendes from the Open API spec. I think he was working at New Relic at the time, and says, look, we have one-to-one relationships between APIs, request and response, but now we have one-to-N relationships between events. Okay? How do we document these is completely different to APIs. So async API allows us to do that, and I'm a huge fan of async API. I think it can help you. Async API allows you to document your service. Async API allows you to document your channels and your messages. Looking at an async API file, I can tell you what messages are going into your service and coming out of your service. It's protocol agnostic. I can actually use any channel or any bindings here and get this information. Very interesting things. When we have machine-readable specifications, we can start building tools, automation, CI/CD, around our event architectures. This is the HTML viewer of that specification, so we can actually start diving deeper here. But the thing is with all of this is, I think there is even more we can do, right? I think there's, on the left, we have specifications, which I think can help you in your event-driven architecture and manage that complexity. We have domain-driven design, which we can pick elements from to manage complexity. But the question I have to myself all the time is, well, can't we build a bridge between the two and develop some kind of tooling and things to help this ecosystem? And then, as I said, this is a problem that I see time and time again, and something I'm super passionate about, and that's exactly why I do open source stuff full time now. So I created this project I'd like to share with you. It's called Event Catalog. This is like a free open source MIT license thing. I do this full time. Has anyone heard of this? Just curious? Cool, nice to see that. So Event Catalog, what is it? Well, it's a discoverability tool for event architectures. Discoverability is a huge problem, okay? Everyone's facing it. If you're not facing it, I'd be curious to know what you're doing. But most people end up in some, as I said earlier, complex mess. So the way this works is you create an event catalog, and we add schemas and specifications. Avro doesn't really matter. It's protocol agnostic. We use docs as source code, and then we can commit this and deploy to any platform. And at the back of it, what you get is some nice static documentation. I'm a big fan of documentation tools. But what this allows you to do is to say, okay, I can start adding semantic meaning to my events. Now, your event, now order-placed event, that's great for developers, but it has semantic meaning to your organization, to your business, to your domain experts. We can start to actually use this and map this. We can start to have the markdown files here and visualize bounded contexts, visualize events, and document whatever we want. In terms of domain-driven design, we can actually start to document some of the domains. Right, we have the orders domain, the payment domain, the subscription domain. Guess what? They have services in them. Guess what? The services are also raising commands, queries, and events. And we can document this stuff. We have ubiquitous language on the right. If you step inside of a domain and say, what is it? What is that lesson that you're talking about? We can actually document and do some things about this and manage complexity. Because once we know and we start to document things, we can also start to visualize things. We can have things like this, and we can simulate message flow between our architecture. We can dive in and actually get control of this beast that is growing. We can see there are commands and queries and events and channels. This is a Kafka channel as an example on the events at the end here. Now, if you don't want to manually do markdown files, there's also integrations, SDK integrations. I can integrate with any broker in the world. This is async API integration that you can document and help your teams get further. Even moving on, bounded context maps. Can we automate bounded context maps? I believe we can. I believe you can take your architecture and actually start to see what events are going between your domains. Now, you can start to see code smells. Like this event shouldn't be going from that as a private event. Who is consuming that? Why are they consuming that? We start to get control, because without this, I'm not sure what the alternative is. And there are other things here like domain language explorers. As I said, you can step inside a domain, understand a lesson, a course, a user, a customer, because the difference between this and this context is completely different. And that translates all into the events. A friend of mine, Chris Simon, has created this awesome project on GitHub. I recommend checking this out. But if you want to take your ubiquitous language in your IDE, right? So as developers are looking in your events and doing things, they can hover over these terms and start to see what they actually mean in a business context. So I think some interesting things and synergy going on here, and I'm working with Chris to integrate some of this into Event Catalog. But as I said, I'm super passionate about this. It's a problem that I see. And as I said, if you have this problem, I'd be curious to chat to you. But I'm just a dude that does this full time and pretty much doesn't get paid for it. But I'm super passionate about it, and I hope there is value in there. If you want to join me on that journey, feel free. We have like over 1,000, almost 1,000 on Discord, 20,000 catalogs in the world created, and I don't know where it's going. So there are things I'm trying to do to help with complexity. And I feel like, can domain-driven design, taking a step back here, can DDD help us? I think it can. I think the alternative is big balls of mud. And if you aren't building big balls of mud, again, I'd love to hear why not and what you're doing to solve it. Because I think if we step away from implementation first, it's very, very tempting, okay? And actually think about behavior first. Can domain-driven design help? And equally, can governance and standards and open specifications help? I think it honestly can. And I think you can honestly manage this complexity with event architectures. And I just want to summarize right at the end and give you loads of resources so you can dive deeper. I mentioned at the start of the talk that there's this implementation trap, that it's so easy nowadays to just get a message and chuck it onto a queue. You can literally do this as an SDK call in the cloud, wherever it is, even locally. This introduces complexity, accidental complexity. Many people, as I said, are in this mess one way or another. And you see this, and it's all down to contract coupling, request coupling, and all sorts of things. And as I mentioned, this implementation versus behavior, I think there are things we can do with domain-driven design to use that to help us. And the key really is, the biggest takeaway there from domain-driven design, I think, is just working and bringing people closer together. And how do we do that? Again, domain-driven design tells us, and teaches us about domain discovery, about event storming, or event modeling is another one you can use to actually just start to look and understand these terminologies, the domain events, what goes inside our events. I like to do event storming to the next level, which is we start to talk about schema design and what goes inside these things. These can all, again, as I said, control that complexity at the end. When we start to communicate between contexts, we can actually use bounded context maps. Right? And remember what I said, you are conformist by default when you consume an event. You are contractually obliged to that event, to that producer. Is that something you want or not? Remember, it's a default action, and these things, there are things out there that might be able to help you avoid some of these nuances and complexity that comes in. As I said, luckily for us, there's loads of open source specifications, tools. If you're interested, I highly recommend just using cloud events, to be honest. If you're getting up and running, because that's an emerging standard and specification, and I highly recommend async API. Fantastic community around that, and it really just helps you write machine-readable specifications. So I think we can. I think we can use domain-driven design, manage complexity, and move away from this implementation first. In terms of resources, at the end, I've created this book ages ago. Has anyone seen this? Just curious. to a few people. So about 2 years ago, it's about 120 visuals on here. So this is free. You can download this. It's just a thing I did. So it talks about event storming, talks about domain-driven design, events, what goes inside your payloads, all sorts of things. I'm just super passionate about that topic, so I just create this thing for free. And then with that, if you want to dive deeper into any of the talks, any of the tools, any of the things I spoke about, all the resources here are on GitHub. You can download that, and you can contact me on X or Blue Sky. My Blue Sky handle is like an OG Blue Sky handle here, and LinkedIn. But I appreciate your time this morning. If you've got any questions, I'm here all day, and just thank you very much for listening.